Dear students, good morning. Today's topic is a linear search, that is sequential search. So this is a basic searching techniques. It comes under brute force method. We know that brute force technique is a straightforward approach for solving a problem. Usually, it is directly based on the problem statements and definitions of the concepts involved. So we have an advantages in brute force techniques, that is it is of a wide applicability and that also of simplicity, and it is reasonable algorithms for some important problems. So the examples for this brute force technique is matrix multiplication, our general sorting technique, and searching techniques like linear search, binary search, and string matching. Then disadvantages over brute force technique is it is rarely yields efficient algorithms. That is, it is slow and it is not as constructive as some other design techniques such as selection sort, bubble sort, sequential search. These are examples. So now we are going to see about sequential search, that is linear search. This linear search that is defined as a sequential search algorithm that starts at one end and goes through each element of that list until desired element is found. Otherwise, the search continues till the end of the dataset. This means that it compares successive elements of a given list with a given search key. So here the input is a list of elements. List of elements like 10, 50, 30, 70, 80, 60, 20, 90 and 40. So the array size is 8. So it starts from 0, the index between 0 to end with 8. So we have 9 elements here and we have a search key to find. Here search key is of 20. So if this 20 is found in the given element, then we have to return the index position. Or else, if for example I'm giving us 22 the search key, this 22 is here in this list of array? No. So it is written as -1, that is no matches found. So this is a basic beyond sequential search, that is it compares successive element of a given list with a given search key. If the list is exhausted without finding a match, it is called as unsuccessful search. So see in this example, we are going to find 20. First it will start from the starting index value 0, 10. Is 20 match? No. Then it will move to incremented to second index position 1. 50 is 20 matches? No. Then it moves to a next value called 30. Is 30 and 20 equal? No. It moves to next index value 3. Is 70 is equal to 20? No. So then it moves to next value 80. Is 80 is equal to 20? No. Then it moves here 60. 60 is equal to 20? No. Then 20. 20 is equal to yes. We reached destination. So it is on the index value as 6 here. So this is sequential search. Just we are going to find whether the key is present in our given list or not. So this how the sequential search works. First step is we have to read the search element, that is target element in the array, that is key equal to 20. Then second step, set an integer I is equal to 0, that is first value, and repeat the steps 3 and 4 till this I reaches the end of the array. Then we have to match the key with array of I, that is first time array of 0, then incremented to 1, array of 1, then array of 2. Likewise, we have to search up until the end of the array. Next, the last step is if the key matches, we have to return the index, that is in which index the key is present, we have to return that index value. If the key is not present elsewhere in the array, then we have to return as not found. So this is the algorithm for that linear search. So first step is implement sequential search with a search key. Then our input is n elements and also we need a search key. Then output is the index of the first element in of 0 to n minus 1. You see whose value is equal to k. This search key is found in the index, we have to return that index, or else we have to return as -1 if that search key is not in the index value. That's it. So first step, we have considered E of n is equal to k. Our search value k is C of n. Then starting index is I is equal to 0. While we have to continue until match found. So while A of I is not equal to k, we have to increment. Then if I is less than n, then return as I, or else we have to return as -1. That's it. So the algorithm is, we have to first take the search key as E of n, and first index value I is equal to 0. We have to check from the starting position. So A of I is not equal to k, we have to increment, or else we have to return the index value. If not found, we return as -1. This is the algorithm of sequential search. So consider this example. Here the arrays contains an element, set of element as 10, 50, 30, 70, 80, 20, 90 and 40. This is an unsorted array. In case of sequential search, the array may be of sorted and unsorted, not a problem. But in case of binary search, the input must be of only sorted array. And here the key is given as 20. So as per our algorithm, sequential search starts from index value 0, that is I is equal to 0 is the first. So it starts from 10. Is 10 matches with 20? No. So it move incremented to next value I plus 1, that is 50. Is 50 is equal to 20? No. So next it will check this next. It incremented to 30, that is index position 2. Is 30 is equal to 20? No. Then it moves to index position 3. Is 70 is equal to 20? No. So it moves to next position 80. So is 80 is equal to 20? No. So it moves to next index position 5. Is 20 is equal to 20? Yes, we got an output. So it returned the index value as 5. We reach the destination. So here the table first one is comparison used in sequential search of unordered list. If our given input is of unordered array, unordered list, then we have three types of complexities here, that is best case, worst case and average case. If the item is present in unordered list, the best case is 1. If the item is present in the worst cases n, yes, we have to search it completely. Same in average case, if the item is present, it is taken as n by 2 of the array size. But if the item is not present, we have to search entire list. So all the best case, worst case and average cases of n. If the item is not present, that is in case of unordered list. It is in case of unordered list. If the comparison used in sequential search of ordered list, this is for ordered list. In case of ordered list, if the items present, it is in best case is 1. If in worst case, it is considered as n. It is in average case also, it is considered as n. Same case in items not present, the best case is of 1 and worst case is n and average case is n. Why here item not present is n means it is of shorted list. So we know that the item is present in a shorted order. So at the first time itself we will know. So that the best case is 1. So we try this example. Suppose if you want to do a sequential search of the list 15, 18, 2, 19, 18, 0, 8, 14, 19 and 14. So how many elements we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So all together we have 10 elements. So array starts from 0 and ends with n minus 1. So 0 to 9. So now the question is, how many comparisons would we need to be in the order to find the key 18? Key 18. So here in our question we have 18 presents 2 times. So we know that sequential search start from index value 0. So we'll return answer as I is equal to 0 and I is equal to 1. So our answer is it will return the index value as 1 because starting first position itself we got the answer as 18. So it won't traverse to the next place. So the answer will return as index value as 1. So this is best complexity analysis. So best case the key might be present at the first index, so it is order of 1. In case of worst case and average case, it is order of n. It is in case of unsorted list, as we saw earlier.